electromagnetic radiation is incident on a clean metal plate. Electrons are released from the surface of the plate. Which statement is correct? A. The energy of a photon is directly proportional to its frequency. Yes, it's correct, because we know a formula that energy of a photon is hf, where f is its frequency, so it's correct. But let's consider other options. B. The kinetic energy of released electrons depends on the rate of incident photons. Rate of incident photons is actually intensity of light or intensity of electromagnetic radiation. It's not true. Why? Because the photoelectric effect is a one-to-one interaction between the incident photon and an electron, and the equation is it's actually low conservation of energy. Energy of the incident photon, HF, is equal to the work function plus kinetic energy of the released electron. And if we increase the rate of incident photons, we just increase the number of released electrons. But for each electron, kinetic energy depends on frequency of the radiation, or frequency of the incident photons. So the kinetic energy of released electrons depends on frequency or energy of incident photons. But if we consider D, the rate at which electrons are released depends on not frequency, rate of incident photons or intensity of radiation. If frequency is the same, but if you increase intensity, it means more photons per second, so more released, more number of electron released, and it means that current increases. And C, the photoelectric effect demonstrates wave-like nature of electromagnetic radiation. Is not true, because if it would be true, and if we would consider incident radiation like a wave, it is possible an electron to be released for any frequency. Why? Because a wave can build up energy with time, up to this energy to be equal the work function, so that electron could be released. But it's not true, because there is some threshold frequency, the minimum possible frequency of incident radiation, so that electron can be released. And actually the photoelectric effect demonstrates particle-like nature of electromagnetic radiation. Why? Because it's one-to-one interaction, and if energy of one photon is greater than work function, hence electron can be released. So it's not wave but particle nature. It demonstrates not wave but particle nature. And that's all for this question.